ignition. Okay. Okay, so ladies and gentlemen, today we are going to go through, as the title of that suggests, we're going to go through some material on the three different mechanisms that Spark uses to maintain information on large data sets. And there's these three different mechanisms represent, in fact, three different eras where mechanisms have been used in Spark's short life. Just as a brief reminder on Spark, it's a platform for cluster computing that's serving as a key platform for data science. It sought generality and high performance. Generality to support many types of work around the data science area, whether it's large-scale programs running in a very repeated way, such as to generate results on a website, like on Facebook or what have you, or on the other hand, exploratory data analysis. And a second major emphasis is performance. And indeed, there have been real performance constraints extending from some other recent technologies, such as Hadoop, a map-reduce framework, when it comes to machine learning algorithms. They're great for certain tasks. The map-reduce mechanisms captured in Hadoop, but they tend not to be that performant, not that high in their performance when applied to iterative data science algorithms. So, so Cassandra provides a component that includes many different elements. That includes an SQL dialect here, Spark SQL, support for streaming, for graph analysis. So this would be for networks, for example. You can analyze networks such as might apply on LinkedIn or Facebook or Twitter, where a given person might have many followers, for example. And then for machine learning. And it supports a variety of existing infrastructures, very importantly including Cassandra, which will play a big role for us, both in class and particularly in your projects. So some key advantages: distributed processing over farms of computers as well as over CPUs on a given computer, over these different computing units, and a very memory-conscious computing style, which allows you to specify where to keep things in memory if desired, but where things can be performed incrementally because of laziness. Things are immutable, which allows you to discard whole data sets of the sort we'll be working with and recreate them, if that's detected or thought to be desirable from the standpoint of saving memory right now, so this other computation can proceed more quickly. So rather than just keeping data around in a dumb way, it actually can try to make informed decisions about whether to recompute it, when to recompute data sets, and when to retain them. Okay, and we're seeking to avoid a number of anti-patterns that I talked about last time. So we're going to be seeing a central role of immutability. These data sets will be immutable. If we wish to add a new column to a data set, we will get back a new data set. If we wish to map a given element of a data set, we will get back a new data set. So in short, we're not modifying data in place, we're creating new data sets. And that allows for sharing, and that allows for data sets to be thrown away and recreated at will. We also keep around information on the provenance, the schema, the lineage that gave rise to this certain computation, and we'll make use of laziness along those lines, so work doesn't get done until it needs to. We will soon enough, not today, but soon enough, we're going to talk a little bit about how this all maps to physical resources. And it turns out that these resilient distributed data sets and data frames and data sets, all three of which we'll see today, we can choose to specify how those map to physical resources if we want to. And it behooves us to be careful about how we use them so that we are processing data in place on a machine rather than willy-nilly exchanging data across a network. Okay? This notion of partitions will come into play here, where we have data partitioned off into different machines, each of which might be operated upon predominantly locally, and then little bits of data get exchanged. Maybe the results of reduced computations on this given thing, a summary of the data performed mostly locally, and then just a few data items get set back to other partitions so it can continue at a broader scale. This will be quite important in this notion of reducing shuffling. Okay? Now, when it comes to Anahita's work, and work that Yang-Chin will likely be involved in down the road, the notion of shuffling is also very important because it has to do with exchange of data between different computational units. So here it applies particularly between machines, because that's where things are really slow, sending data over a network versus just reading it from memory or even from disk. But it also will apply when shuffling things between different processors in a GPU context. Okay, so we're also going to see that as time went on, there was more attention paid to how we could achieve type safety. Okay, meaning how we can manipulate this data in a way that errors that we put in our code get immediately detected, rather than waiting until they blow up in someone's face. Just when someone clicks on something on the website, it throws an exception. Okay. So I talked about this this last time, but what we're going to be seeing is that the things we'll be working with will be able to target multiple machines in the background, and if we wish to dictate some of the parameters of that, we can, but a lot of what we'll be seeing will go on behind the scenes. Okay? Okay, now I asked you folks to take a look at this chapter. So hopefully you've read some about RDDs, the fact that they are resilient, that they know their lineage, that they're distributed, they're resilient in the sense they can be recreated, they're lazy, etc. And we're going to take that to look at these additional items, which are incompletely covered in this book. DataFrames and their type-safe relatives, datasets. Okay. So that, ladies and gentlemen, is the task that lies before us. And last time I lost some initial comments on Spark. So I will probably periodically be making sure that my recording software is working okay. Okay, so rather than talking about these in the abstract, I'd like to dive into this. And if anyone does not have Spark with you, please pull up to someone who does, because I want you to see the Spark shell. Okay, if you don't have a computer with you, or you don't have Spark installed on it in a way that will allow you to access it, please do pull up to someone, because this is going to be an interactive task. Okay. Okay. So I'm gonna cancel out of this. So let's come back. This was actually the Spark shell. Spark shell runs. Scala is Spark's native language. Yet another wise decision made by the Spark designers. And so when you're in a Spark shell, you can type things in Scala. Okay, and we will be doing that in spades. Okay, so I'm going to start up Spark shell. Now, there's a couple things that you should note when it starts up. And one thing is that it loads in a swack of stuff. Here it's loading in a bunch of libraries from various locations. And you'll notice it has some initial configuration here. It gives us some information, and this is valuable for us to use it properly. So we can, for example, set a logging level to have it report more verbose information about what's going on or what's going wrong. or less. And it also will provide information about useful variables that it predefines. So a key one will be this one, SC. And that, ladies and gentlemen, is called the Spark context. Okay? And we'll be using that a lot today, and we'll be using that a great deal in many future sessions. You'll notice that it also provides a little, this is a URL, and this is a URL to what's called the local host. So when you see 127.0.1.1, that's not pointing to a machine run by Merlin or Greg. This is in fact pointing to what's called your local host, which is a local web service. And so if we go over here, and I should probably not combine it. Here we go. This is kind of the mothership. I'm going to point it to this. And what we'll see is actually there's a nice little interface here which provides me access to understanding of what Spark jobs are submitted, what stages they're in, etc., what stages they have, etc. Now, right now, I don't have anything running yet, so there's kind of less information here, but if you go to environment, we could see some information on things loaded. Now, a couple other things. Ladies and gentlemen, you would do well to familiarize yourself with the basic mechanisms of Spark because it illustrates a lot of state-of-the-art software development techniques and technologies. You'll notice it refers repeatedly here and here in Ivy to this system called Ivy, which can basically take care of automatically getting jars, appropriate jars for use by Spark. So it can actually download library files, for example, automatically. And this is reflective of a current generation of software tools, which rather than forcing you to go do all that manually and hard code what jar you're going to be using, what library, it can actually go out and it goes to a Maven central repository and downloads and can download jar files for your project that have a certain version number, etc. So it goes out and can grab those down automatically. That's a good question. It can, you can add in, and I'm going to have to be careful about this. Winchell, you're going to have to check my comment about this. So there's a couple layers of things. Some of these items here are built in for Spark. They're things that Spark automatically loads. Some are things that I configured Spark to load by creating a configuration file. And Winchell, in fact, was as he is in so many areas, my key go-to person for this, and he gave me guidance on where to go for the config file, okay? So that every time Spark runs, it will load certain jars. A level up from that in terms of dynamic components is you can actually specify when you start Spark, please load these libraries on the command line. So you say Spark shell minus da-da-da-da-da, and it will actually load it. Now, Winchell, when you do requires in Spark, can it actually go and grab the jars at that point? Do you know?
To my understanding, it only grabs at the current directory. It doesn't really go to Maven.
It doesn't go to Maven in that case.
Yeah, I think it's not that smart.
Yeah, so it can load them from the local directory, where they can be in a folder called jars, I think it is. But it won't actually go out to grab them via Maven. Okay, so this will be this little environment, although it seems modest, unassuming, and perhaps even boring right now. It'll get more interesting as we end up sort of playing around with this system. Okay. So, ladies and gentlemen, you should be in Spark Shell. You'll notice this is version 2. This is really important. Spark has changed a lot over the years, and it, when following along my examples, from the book, you'll recognize there's actually differences, and there's big difference pre-2 to 2. Okay, pre-2 to 2 has a big jump, and Spark is continuing to evolve. As a reminder, Spark came out of what's now known as the AMP lab at Berkeley, and they're evolving the stack over time. Okay, ladies and gentlemen. let's explore a few things within Spark here. Okay. So one thing that I'd like to do here is I'd like to show 3 different ways that we can load information in to Spark. Okay. That we can create a data set from a defined source. Now, these are going to complement ways of loading it from a database, but I want to show you 3 different mechanisms using different approaches. Okay, so one of the things that you're going to find is that, perhaps not surprisingly, since Spark is so solidly placed on top of Scala, is that Scala mechanisms are key, and one of the key ones is something called this case class. Many of you will remember that, case classes. What are case classes? Can you remind me? What are some distinguishing features of case classes that distinguish them from other types of classes?
Pattern matching.
Okay, great. They provide built-in support for a lot of mechanisms. One of the mechanisms are things associated with pattern matching through support for what 2 methods?
Apply and unapply?
Apply and unapply, yeah. And in fact, the apply method means they have a companion object. It's because it's an object. They have a companion object by the same name, so you can say whatever the name of the case class is. Let's say, hey, let's define a case class. Let's not talk. Enough jargon. Person, case class person, name string, age int, and income double. Okay. So maybe what I'll do is I see some craning going on. So let me see if I can lift this up a little bit. But this is what we want. Okay. Okay. This is what we want. Case class person, name is a string, age is an int, income is a double. Now, by virtue of defining that, we actually get a swack of different things defined. It turns out that there'll be a bunch of them associated with a bunch of information associated with that. There'll be both a class and a companion class. Do you remember that? Remember that? Okay. So, ladies and gentlemen, there's going to be a companion class called person, and we're going to be able to say, for example, person, NDO, age 48, income, 1.0.
That's a lot.
I'm just not telling you the units.
Yeah.
Okay. Okay. So, ladies and gentlemen, this created an object of person whose name is NDO, is income, or it's age this and income that, right? And I can do val p1 and p1 equals this, right? Here we go. And it turns out that that also there's been defined behind the scenes an unapply method, which allows me to do something like this, right? Val person, person, I think this is the syntax if I don't remember properly, name, age, income equals P1, for example, and it's going to extract these things for me, right? It's going to destructure it, as we say. It extracts it, right? Yeah. Okay, so ladies and gentlemen, so here we have an indication, both our ability to do this, the fact that we didn't have to say new person, we just said person, and the fact that we can do this. We have an apply method in a companion class and an unapply method in the main class. Okay, and there's a bunch of other methods that are defined, right? So what I'd like to do now is to take advantage of these, because it turns out that case classes are Scala and Sparks, primary ways of defining the types associated with data sets and data frames. Okay, but first we're gonna do a bit with RDDs, with these resilient distributed data sets. Now you should have been reading about those here within this context, within the context of Chapter 10. So I'm not going to go into this for incredible detail, but let's try a few things here. Okay, I'm going to create a population of people. Okay, how do we do that? Anyone remember? I want a population of 1,000 people. How do I do that? Okay, yeah, we can do fill, right? We could do something like sequence, or we could do array if we want to be very particular about it, right? Maybe what I'll do is an array, okay? Array dot fill 1,000. What's that 1,000 indicate? The number of people in it. And then what do I give it next? What goes in between these parentheses of some beckoning? Okay, so I heard some utterances which are indeed close. So I heard object of a class. What am I giving it here, though?
Person.
Okay, am I actually giving it a person here?
Well, no, you're giving it a function to a person.
I'm giving it a thunk. I'm giving it a way to compute the persons, each of them in this array. I'm giving it an expression that we run to generate each of the people in the array.
Does it take the index 0 to 1,000?
No. If we wanted that, we do, instead of fill, what would we do? Anyone know? Tabulate. And that would actually give us. And by the way, you can do that in 2D, which is sweet. It'll give you X and Y or I and J. Really nice for doing, sort of 2D tabular data. Okay, ladies and gentlemen, so let's do this. Person. Remember, we have this apply here in the companion class, so we could do that, right?
And this should be a
Oh.
Should be called by name or
here, copy this. I neglected to do something.
import random?
Yeah. Okay, import. I just copied it. So java.util.random. Okay. And I'm going to import, implicits. So what am I? Oh my gosh. Okay. 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 Yeah. Sorry.
Pair programming is very useful.
Indeed. All the more so when one person's sleep deprived. Yeah, it's good. Actually, it's a very interesting observation about pair programming, ladies and gentlemen. Not that it applies here, but pair programming is useful even when you pair an expert with someone who's a novice. They can still find suggestions to improve it. So don't think that pair programming is something you have to wait till someone's up to speed to participate in. Someone can participate usefully in pair programming at any stage, and often it helps them learn, actually. Okay, so let's go back to our thing here. Okay, here we go. So what we're going to have is next string of 3, right? What's that going to generate?
A bunch of Chinese people.
but okay, so that may be. But what in particular is this going to generate?
Random UTF-8 string coordinates, Unicode.
Well spoken. It'll be randomly generated 3 character names where those 3 characters, each of the 3 characters are drawn from UTF-8 encoding, right? Okay. Next, we're going to do next int, and with this we can actually specify a maximum value. So this will take a value between 0 and 99. I believe actually it may do 100 as well. I can't recall if it includes or not. And then we'll do next double, but next double does something between 0 and 1. Okay. So maybe we'll multiply it by 30,000. Okay. Okay. So there we go. There we go. So actually, let's do it times 50,000. 50. Okay. For reasons of my own. Okay. Okay. Are we okay with this? Okay. So I would argue that this is a thunk. Why do I say it's a thunk rather than an actual? If you looked at this in isolation, not knowing anything about Scala, what might you think this does?
Generates a single person.
Generates a single person and passes it in to be repeated 1,000 times. But instead, what this passes in is an expression to evaluate. This is an example of what? Call by name. Okay.
Instead of call by value, would that be the opposite?
Correct. Correct. And back in the 70s, there was there were programming languages that used call by name as their way of calling functions. That was their primary way. And then there were programming languages that used call by value. And basically there was a lot of thinking in the programming community, and it came down on the side of call by value as the standard is more clear, right? Okay, so here's our population, right? And it is a varied set. Some of these I don't even. This looks like Korean, and I don't. That almost looks Turkish. I don't know with the right. Like Uz good. And I don't know what this one is, but anyway, okay. We won't comment on their nationality. Okay. So, ladies and gentlemen, this is good. Now what I'd like to do is to say the following. I'm going to say val population RDD. What is RDD? For what does RDD stand? Resilient
Distributed.
Data set. Okay. C.parallelize. Oh my gosh. Parallelize. Am I spelling that right? I get confused with where the two L's go. Yes, it's correct. Parallelize population. Okay? And here we get an RDD back. It's an RDD of person. Okay? And we could then apply various operators to it. So if you do person RD, a population RDD dot, and I'm doing tab here. What I could see is a bunch of options here, right? So for example, I could do a filter, right? Filter by, and this is an RDD of person. So what might I filter by, for example?
Age.
Sure. So age is less than 35. We're going to look for youth.
30-year-olds or youth?
Okay. So 25. Okay. I didn't want to be controversial here. Okay. So we could go and filter here, and here we will have a filtered data set consisting of whom? Individuals under 25, right? That's good. So something that we could do here would be to...
Parallelizing.
Sorry?
By
Parallelizing. Yeah.
What did you do? You shuffled the data into different codes?
Correct. So it turned into an RDD, and one of the things that's involved in that is it actually prepares to put it onto different partitions. So let's suppose that this didn't include 1,000, but it included, 100 million data points, or 10 million data points. That's not an exaggeration. I mean, if you think about Facebook's scale of data, or the scale of data coming in from Twitter. Kurt did a statistic the other week during the summer. where it said, I can't remember how many tweets it is per second that come in the world. Sorry?
I did.
Yes, you looked it up. Yeah, yeah. And you told me it was, I don't know, 8,000 tweets a second or something like that. If you're talking about those sort of data sets, 100 million data points may not be that bad. And in fact, some of the data sets with which Narges has worked, or that you will work for this class, could easily involve that from Ethica, right?
Yeah.
So there,
So
it
if
will
you
actually
don't
really
define-
helpful. It puts it out over a farm of machines.
Mhm.
So this parallelization gets it ready to do that, but it actually will assign it to different partitions.
But
et
if
cetera.
you don't define it, it doesn't do it automatically. I mean,
It-
you
It will. It will actually do some automatic work. And here, what it's probably done is, and I'm trying to remember the thing off the top of my head to ask it. There's actually a way to ask it to sort of print out with the mapping to partitions, and we could probably see it through this web interface here.
You have to do something that takes more than a second to calculate.
Exactly. But we could see something about how it's mapped to the resource. In this case, what resources might it use? We did not. I did not ask you to set up clusters as
course
part
of your mesh.
for today. Yeah, it'll be do it to course of my machine, for example. And I think in this book, actually,
You can define it even.
there's
How
an
many
example.
threads you want.
Yeah, that's right. Absolutely, you can define the number of, and in fact, you can go into much more detail with the partitions that you want to have in place, etc. Okay, we'll come to that, but for now, I want to get some basics here. So we just did a filter, right?
Duct tape.
Sorry.
Duct tape.
Yeah, let's do no. Here, take 5, right? Right. Okay. Okay. So, why is it taking long now? Why was it so quick before? But this is taking a long time.
Master goes to ask from each partition.
Well, yeah, and what went on here? So this returned an RDD, but did that data set, if we say, was this thing actually at this time, did it actually include just people who are less than 25?
Lazy, it didn't.
It was lazy. Ladies and gentlemen, this was something that knew that it needed to compute the age less than 25, but it didn't actually perform it. This was what's called a transformation, and it didn't actually undertake that transformation until an action was undertaken, this one here, where we actually required the data to be computed. Okay? So we could go and we could look at, for example, here, this, and I think it's a command called print debug. Is my memory right? It's a debug string which will allow you to sort of trace. It's a to debug string. That's what it is. To debug string. And what this will actually print out is the lineage, whence it came. So this got created by parallelize, and then it got filtered, right? And we could further, for example, ask it to count, right? Sorry. It's not a member of long. Count yields a long. We could ask it to fold it, to reduce it. We could ask it to further map it potentially, right? There's a flat map, and I believe there's a map out here as well. So let's try map here. Yeah, we could map, and we might map, for example, this to something like. So this would be, what sort of input would this be?
Age or income or something?
A P is a person.
Oh, I see.
And we might map it to, for example, their age times their income, right? Age times income. So here we have several successive computations going on, right? Here we had one that was created by parallelize, another that filtered it, and another that mapped it. Okay? This indicates how it can compute this thing. Now, Has this thing been computed yet for everyone in the population? Not yet. Not until, it's lazy, right? Not until we go and we want to say we want to force it, right? And so actually, yeah, you have to do the take. Sorry, I'm streaming it. Okay, here's take 5. Here's a bunch of individuals, sort of lifetime earnings, right? Lifetime earnings. Okay. Okay, ladies and gentlemen, this is an example of an RDD, and RDDs were the first generation here of data sets, and generally it's a somewhat lower level interface. As you can see, it can allow for type safety, right? I mean, take a look at this. Here we're specifying things in terms of the data structures. It knows that there's an age field. It knows that there's an income field, right? And we're filtering accordingly. So this is actually type safe. I mean, if we typed, foobar here, what do you think will end up happening?
Looking for type H, found type foobar.
Yeah, it'll say it right away. It's not going to wait until I compute it. It'll say, hey, I don't know what foobar is. So this is, this has some strengths there, but it's a fairly low level interface. You notice that I say we need to specify the schema to use, the fields and types that apply. When did we specify the schema here? How does it know age and income? How does it know that?
Because we turned population into an RDD.
That's right. And population was defined with a what? Oh, this is a long. It's a case class, ladies and gentlemen. So Scala or Spark, writing atop Scala, case classes are a key way of communicating. Oh, this is very long.
Take from the corner.
Okay. Well,
Okay.
yeah. Here we go. I could also maximize it, but then I want to pull it up a bit for people. Okay. So case classes are a key way of communicating information. In fact, they are the main way of communicating this when it's not specified by the data structure. Now, there are certain data structures that do specify some type of information. One of them that we'll be working with in this class is a group of JSON files, okay, where actually the type information can be included and deduced automatically. And it will try, although in my experience often fail, to deduce it from CSV files. We'll sort of look what's there, come to some conclusion about it. And often I find the conclusion. Sorry?
They don't understand. They see it as a stream?
Often a CSV file?
Mm-hmm.
So a CSV file they'll turn into a data frame, for example, but they try to analyze the types to turn into a data set, and often they make the mistake of thinking, oh, this is just a string, instead of that it's a double or an int. So often you have to give it extra information for that. Probably it will improve over time. Okay. So, ladies and gentlemen, we've seen some features with that. This is an RDD. Now, RDDs, as I say, they have a big sort of library of things you can do with them, and you'll note compared to other of these types of whoa, okay, I thought others of these, that the operations on RDDs tend to be somewhat lower level. Okay, you notice there's a number of things. Get num partitions. So here we could ask, right? Get num partitions. I think it was partitions. 4 partitions. Why 4 partitions?
Of course.
Indeed, ladies and gentlemen. So it could be run on my different cores. We could ask, what's the storage level associated with this? In other words, where does this have to be stored? Is it in memory? Is it on disk, etc.? We can get that sort of information about how it's handled there. We can also ask what partitioner is being used, and this is basically going to be something that helps dictate where where information is stored. So we can put in place a custom partitioner. We can also ask about the partitions. Now, none of this we're going to have time today because I want to talk about these other types, but you'll notice that it's talking about various partitions associated with this RDD, okay? And we could tell it to repartition so that it stores the data on different places than it has been. Now, this issue of partitions, where the data is stored, is much less of an issue on your local cores than it is if we are farming out across those machines out there. Why is that? Why do I say it doesn't matter quite as much on your cores in terms of where data is stored? Yeah, these are shared memory here. And so the different cores are going to be able to look at your disk or look at your memory without problems. But that's not true on those machines out there. For those machines out there, it's quite expensive to talk to another machine, to coordinate with another machine, to pass information to another machine. And so there, this issue of what's on what partition makes a big deal, a great deal of difference. Okay, you can also see here that you can, for example, do what's called persist and unpersist of data, and associated with that is this thing over here called caching. Okay, and basically persisting can allow you to record an intermediate data point, okay? Something that that is actually you're going to be able to come back to at a later point for computation. It can materialize the computation. Caching can allow it to be stored in memory, basically saying, look, I'm going to be operating this data set again. Please don't throw it away. I'm going to be operating this many times. It gives us a hint that it's going to be used.
Is there a difference between that and persist? What would be the difference?
With persist, I think you can specify where to persist it on disk, etc. But I'd have to refresh my memory for this. So let's go check that out. So if I were to say persist here, this is actually keeping it, I think by default it's keeping it in memory. Winchell, do you remember with persist the difference in that and cache? I think cache may be in memory and then persist is more general. Yeah, I can't recall off the top of my head either.
If you cache something, like do you risk losing it again because cache gets refreshed by other work?
So I think that's a good question. Can it be thrown out if it's cached? I think I think the answer is probably, but then it knows how to sort of recompute it. But again, I need to check with this. So persisting is often used for situations where you do have repeated access to things. Cache is used in a similar way, but the exact semantics you need to look up because I don't happen to remember it here. But the point is that what's that?
Someone here online said what you said. Cache is memory only. Persist you can specify.
But the memory, where in the memory hierarchy it lives. Does it live on disk or memory or in memory or disk, etc. Okay, so that's good to hear. Okay, ladies and gentlemen, so the point is that this RDD, and we're going to come back to it, it has a bunch of particular lower level components we could ask. You'll notice it also has two additional things. It has this thing called 2DF and 2DS. Okay, so if I say 2DF, what comes out of this? It's a data frame, ladies and gentlemen. It'll be this next level up of, and where is it? Here it is. Data frames, which
DS or DF?
Well, it's a data frame. a given thing is a data frame, but it's data sets, data frames, and resilient distributed data sets, data frames, etc. So here's a data frame, okay? And this data frame, so I could say DF population, val DF population, all right? Now this is going to have a somewhat different set of calls that I could perform with it, and how I manipulate it will be different. And then you'll notice that there's also a toDS, okay? And here, if we declare a DS population, this will be a data set of person. So data frames of person, they tend to, as we'll see, they tend to be less type safe. They're more optimized for certain things, but less type safe, which means you're not going to be able to catch errors until runtime for a fair number of things. But they do have a somewhat higher level API. They can allow you to compute statistics on things and aggregate and do queries or what have you. Data sets tend to be kind of the best of both worlds. They have support for typing, strong typing, but at the same time, higher level operations through data frames. And these were brought in at different times. I think data sets only arrived with Spark 2.0, but a big investment in both of these was optimization. And one of the realizations here is that the strong typing information, the fact that you know what you're dealing with, allows you to be more intelligent about how you manipulate it, what information you exchange, what information is needed. It allows you to be more specific to the needs for this particular case rather than just using very, very general mechanisms. Okay. Now, a key point here is that even though these existed earlier, 3 years ago, 4 years ago, probably 4 years ago, this is what you had, and then data frames came in and data sets, you're going to be using all types. Sometimes you'll go down to RDD level to manipulate certain things, and sometimes you'll operate at data sets, and sometimes at data frames. They have somewhat different APIs associated with them. Okay, and here's some comments. Data frames, I think many of you folks are familiar with from one of two contexts. Either number one, R, data frames you manipulate as a major abstraction in R with columns, or number two, the machine learning course, where you'll use data frames in Python. And these are quite similar to them, but data sets give the benefits of data frames with type safety and with enhanced optimizations. Okay, and this includes improved memory management. Okay, now I'd like you to play around with this a little bit here. Okay, so let's go back to our thing here. We've seen how interoperable there are. We can go from one to the other. We can go from a RDD to a data set, to a data frame, etc. And a lot of the concepts are going to carry over. They know their lineage, they're immutable, all those sort of good things. Okay, so let's continue on with our work here. So, ladies and gentlemen, I'd like you to go try the following. I'd like you to import org.apache.spark.sql.sql context. Ladies and gentlemen, SQL, the structured query language, is a key interface for Spark, and in fact very important for dealing with data sets as well, and data frames. Okay, so it's going to be used a lot, and we're going to import it here. So we're going to import this support, and then what we're going to do is we're going to actually create an instance of it. Val SQL context equals new SQL context. Okay, this is going to sort of set up our SQL situation, and we're going to pass it in as its argument SC. Does anyone remember what SC is? Yeah, it's the Spark context. Spark context. Okay.
So it adds it to the.
So it creates an SQL context that is going to work together with the Spark context to do its work. Okay. So it's going to be able to do its work from the SQL standpoint together with the Spark context. So we're not going to have to specify it at every point, in our function calls. It just remembers it. Okay. Okay. And now we're going to import, and this is a little bit confusing. SQL context, all with lowercase SQL dot implicits dot underbar. Okay. Okay. Here we go. So you actually have to create this first, and then you import the implicits associated with it, which basically will involve auto magic jet conversion between things. So this work in Scala on Spark is going to involve a lot of automagic stuff behind the scenes. It knows how to convert things. So if you're dealing, for example, with a data set that involves double precision values, it will let you do some things that you wouldn't be able to do if it contained string values. It knows how to sort of turn it into, or in certain cases, it will know how to turn things into more specialized things, which have operations for doubles of them, maybe an average, which you wouldn't have for a string. Okay, here we go. Implicits, okay. And now, what we're going to do, well, we already created here a data frame earlier for population, but I'd like to go create it again, ladies and gentlemen. So we called DF population earlier, but I'd like to create it with this SQL context in mind, and we're going to issue some SQL like queries. Okay, so we're going to do val df population 2 equals SQL context dot create data frame, and we just need the original RDD that we created way back when. Population RDD. Okay, so we're going to create a data frame, but through this SQL context. So you'll notice something here, ladies and gentlemen. Let's go back to that data frame. Here, actually, it may be that with this library that we don't have to do it, because I was going to say this is a Spark SQL data frame, but so, in fact, was this one here. So it may be that this is just a nicer way to do it with .df if you already have this created. Okay, if you have an RDD created, maybe you don't have to go get the SQL context involved, but we'll probably use it down the road anyway as well. Okay, okay. Now we are going to create a data set now in an explicit way. We could have done 2DS, but I'm going to do it this way to emphasize a point. Val df population. Oh gosh, yeah. Val df population typed equals a data frame. Probably could have been df population as well. Dot as person. Okay, a data frame by itself is generally not going to remember all the details in a typed way of how it's defined, and if the typing involved, it will allow you to issue strings and sort of check those at runtime. But this actually creates, ladies and gentlemen, a data set of persons. So it actually knows a person's contained. Notice that this doesn't. It says nothing about person. Doesn't know about its connection to person, the data frame by itself. The data set does. It's kind of a version of the data frame that does. You could think of it as a typed data frame. So having done that, df population typed, really this is a data set, ladies and gentlemen. Let's just say DS population. Now we already had that, I think, from earlier, but we'll just say that. It's a data set. It's a data set of person. Okay? Okay, so let's use it now. Shall we not? Okay, DS population dot, and we're going to start doing some things which are a little bit unremarkable, but then we'll work up to some more interesting things. Okay. Okay. Dot filter, and in will come a p person, and we're going to filter people who are greater than age 40. P dot age greater than 40. Okay? Count. Okay? Look what it's doing. It was going and...
Find in each partition.
Yeah, exactly. I mean, we could look at that again. It's probably cached it here, right?
Yeah.
But we could do this. Right? Okay. I don't know if you saw that. There was a 4. It was doing computation over my processors. It was sort of coordinating the processor. Let's try that again. Yep.
Stage 8.
Oop. What's that? Stage 8. Yeah.
Yeah.
Yeah. So it was doing some processing over my different processors. Okay. Okay, ladies and gentlemen. So unremarkable. We have 556 who are greater than age 42 in our population. Fair enough. Okay, let's do something that pushes us a little bit more. Age greater than 40. And now, ladies and gentlemen, we are going to do group by. We're going to do a group by, okay? And what's going to be in that group by? Well, we're going to actually, we want to group by something that's fairly coarse. Not in the sense of last night's debate, but in the sense of that it's a larger category. Okay, so we want to group by something that's going to have lots of people associated with each category. Income, it being a double, there's going to be many particular values for income. So if we say group by income, we'd really want to say income category or something like, ranges of income, and that's what I'm going to pursue here. Okay, that sort of thing. We're going to actually group by age. Okay, round. Now, confusingly, round. Round within the documentation. See, so Winchell likes my my exhortations there.
Can you create bins of, for example, income and then?
Yeah, that's what we're doing. We're doing it with age here.
Okay.
Okay. Now, this ain't pretty, but I think round actually does round to it rounds down an integer value, actually. Whereas there's something called rint, which actually does what I would normally call a round, like something that's 4.6, it turns to 5.
So round is like floor, is what you're saying?
That's right. That's as best I could see it, which I find just very disconcerting. But I'm not about to write my old buddies at Berkeley about it. Okay, ag, maybe we should add a floor function. Okay, now, so we've just grouped by this, and now we're going to aggregate. So do you remember grouping by clumps together all those who have the same value for this, right? What is this going to be? I mean, intuitively, what am I grouping by? Here. What?
5 categories.
Yeah, 5 year age categories. Yeah. So this round is going to be, well, if you're 42, it'll be 8. It'll be 42 divided by 5, right? And then it'll be flooring it. It'll be turning it to the lower integer, which will be 8. And then it'll multiply by 5, so it'll be 40. If they're 40, it'll also be 40. If they are 49, it will be 45. Yeah. Good. Okay, so ladies and gentlemen,
So if you just press enter on it now,
if I did this,
yeah.
Yeah, it'll be a relational grouped data set. And I could, let's see what would happen here. It's not a function there.
Cake or something?
Yeah, you basically need to do one of these things. Not pivot table there. That's a pretty nifty thing. We're going to right now aggregate by what? What are we going to aggregate for each such category? What are we going to aggregate? We're going to aggregate over the sum, over the average, aggregate over the average of the income in that category. Now, you'll notice that I'm doing something unusual, perhaps even something disconcerting. What am I doing there? Look at that. Oh my gosh. Okay. There's the average income across different age categories. Let's look at this again. So,
Can you drag it in from the left a little bit?
can.
Thanks.
Oh, mumble. Okay, like that. Okay, so ladies and gentlemen, I filled.
Sorry, we're gonna have to drag it from the right now, but if you can just make it a touch smaller.
Can.
Take order.
Drag right, can. Make smaller, also can.
Right here.
Yeah. Yeah. That's how they'd say it in Singapore. So you were going to say something?
Take order so that we have the ages from, it starts from 45.
Yeah. There's probably some nice way to do that, and be an interesting question of sort of what can I do with this result? Could I sort it, for example, after that, right? What if I okay, mumble. Okay, if I did this, I get back a data frame, and could I sort by this thing in some way, right? Order. Yes, order by. Oh, sweet. Okay, but there's going to be a fly in the ointment that we're going to see in the fullness of time. In fact, the fly has shown its wings. Okay. Do you see this? What's the first column in this result? This result of aggregating. Well, we saw what it was. You notice I did a show, right? And we saw what it was. What's the name of the first column? This, ladies and gentlemen, that ugly thing. See that? Okay. So let's remediate that, okay? Okay, watch this. This is not a thing of beauty, but it actually will work, okay? Dot with column renamed. Okay. And what column are we going to rename? Well, go copy this guy. That's the name of the column right now, in all its fearsome beauty.
I need you to make sure you get your. Yeah, it's a parent that you missed.
Paste. Did I?
On the left.
Sorry.
Right. Yeah. Right. There you go. Right in front of the round.
Oh, did I? Is there? Oh, okay. Yeah, you're right. Okay. Thank you. Good call.
We're group coding now, not just pair coding.
Yeah, this is awesome. This is great. Okay, and let's call it age cat. Age category. What do you think? Good or not? Okay. With column. Oh, it's not a member of the relational data set.
Can you get it by index instead of string?
No, what we could do here, let's take this out here. I'm trying to be responsive to student questions, so I'll welcome these challenges. Okay, I think where we could actually do it is, let's see what this is, okay? This is a data frame, right? Okay, so, there's two dots. We only want one, right? This is just a data frame here. True or not?
Yeah.
Okay. Okay. And then I'll do this. Good or not? Good. Okay. And then what I'll do is dot. Can I do dot order by? Or okay. I think order by has to be done after this, likely. But let's try this. Let's try here. Can I do sweet? Okay, order by. Okay. Okay. And then let's try. And I think we're going to need to do age category. Now here. Now the question is, and I to be honest, I get this confused. Oh, sweet. Okay, watch this. When I was growing up, sometimes the expression for that would be
sweet. Hot
diggity dog.
What's that?
Hot diggity dog. So here we have acceded to the interest of the Anahita. Good or not?
Good.
Good. Okay.
I wanted to estimate my income at different ages.
Well, yeah, I haven't made income age specific here, and don't
Average.
get disappointed. I also haven't specified the units. Right? Maybe these are in top thousands of dollars or something. Anyway, okay. So, ladies and gentlemen, let's do another thing here. So here we've aggregated. We've actually seen rename with column rename. Does this remind you of something a little bit?
SQL?
Yeah, SQL. I mean, with column renamed and SQL, how do you do that? You don't have a separate call like that, but what do you do? As. Yeah, you can do as. I do this as that. But you'll notice a lot of similarity, right? This is almost like a what? It's almost like a where clause in a select, right? Group by, does that exist in SQL?
Yeah.
You bet. Order by.
Yeah.
And when you group by, you have to specify aggregation functions for the larger categories. How do you treat things in it? It's very similar to SQL, is it not? It is. Okay. Okay, so ladies and gentlemen, let's continue DS population. Let's do DS population dot, and let's go see what else there is in here. And you'll notice there's things like reduce and so on. There's also things like select. So we could actually go here and select certain elements from the data sets as they're being computed. So we could actually, if we had additional information, we could, for example, here, dot select. Watch this. DS population dot select. In this case, it's not going to be a very compelling example, but basically we're going to be tossing name, which we don't need. Income, and then age. Okay, and then we could okay. Okay. Select. Okay, sorry. Type mismatch. With column rename, okay, found person Boolean, and instead I need, I see, I need a row to Boolean because we got out, and I think what this is saying is that when we have select here, we're going to get out something out of the select that, this is a DataFrame API, it doesn't actually know it's a person. And so we would have to do a where clause here, where, Now watch what's happening here. What's happening may seem curious, but it has some deeper significance. We're going to do this. Notice I just got rid of that type information, and I'm going to say this. Okay. Similar result, but here basically this caused it to go back to the data frame world where it doesn't have sort of strict typing information maintained that this is related to person, and therefore I had to specify it like this. Now this is actually referring, you may be wondering, what are these $sign things? These are references to what? Columns. Either computed columns or otherwise. So we could do a little bit more work with this, ladies and gentlemen. Let's try this. Okay. Let's do the following. We're going to do okay. To simplify things, time is a ticking. So I'm just going to, rather than futzing around with a longer thing, I'm just going to go back here and I'm going to do stat. Now watch this. If I do stat, now I can get it to compute a bunch of things. These are some high-level things. Covariance, correlation, apply Bloom filter, frequency items, sample by. I'm going to ask it to do a crosstab. Okay? Now, I'd ask you to bear with this. Now, this is one of the kind of confusing things. I'm going to ask it to do a crosstab by age and income, and I'm going to say show here. Okay? And what do you think you'll see? Will it be pleasant or unpleasant?
Unpleasant.
Most unpleasant. Most unpleasant. Boom. Unpleasant or not? Indeed. So let's in our closing minutes, let's contain this beast. Okay. Okay. So what we're going to do here is the following, and I'm showing you some ways around. I'm going to do income. Okay. Okay. I'm sorry for inflicting this. Okay. I'm going to do the following. I'm going to do round. By the way, all this code will be shared with you, so don't worry. You have to if you get something wrong. Okay, so I've got to be careful about this. Round and okay, that's a bug there. Okay. Round of this divided by 10,000. Okay. Okay. Round of that times 10,000. What is that going to do? What's the effect of that? It's going to, yeah, it's going to divide it up into to categories, right? Okay. Now I'm going to similarly. I'm going to undertake a similar trick, ladies and gentlemen, with age, but I don't need round there because it's an integer, so I could just do age divided by 10, and then times 10. Okay? Now, by the way, don't put this thing in front, or else it will try to compute it as an integer. So this is a what? What did I say that this was? It's a reference to a column, this thing. $sign this. This is a column reference. This is a computed column. This thing divided by that. This is a computed column. And this is a computed column. Okay? So let's see what results from this. What results? What do you think will come back from this? Well, it's a data frame with basically two columns. This one is called that, and that one, the second one, is called this. Okay? What do you think? Now what we're going to want to do is we're going to do a crosstab with respect to each of them. Now, we could rename each of them age category and income category, and then do a crosstab with respect to each of these. So let's do with column renamed, and I'm going to specify its current name. The current name is this guy. Boom. By the way, you notice, you know what that 0 is? It inserts that 0 automatically. That's what it is. It inserts it automatically. This is probably the number of digits to which to round it. Okay? And I'm going to call this income category. Good or not?
Yeah.
So if I do this, now I have income category here and then age. And now I just got to do a similar thing with column renamed. You can see it ain't beautiful, but it ain't stinking bad either, at least in my view.
Can you rename column by index of the column?
Yeah. You could specify the column. I don't think you could specify the index just there. You could specify, you can get the column at an index, but in this pipeline syntax, it gets, I haven't found a nice way to do that really sweetly. Okay, we're going to rename this to age category. There we go. Okay, we're going to get something like that. And now, what can we do? We could do a stat, and then a crosstab, and then by age category, and then by income category, and then show. Here we go. Okay, now that, yeah, so this is the income category. Sorry, this is income category. Now, this age category doesn't quite look right, does it? I guess I was wrong. We need to do round. Oh. I got to correct my notes there. Okay, we need to do round. So this is going to be somewhat unpleasant. Let me do this. I don't want you to have to encounter this, but let me just go back and do this, and you can benefit from the learning afforded. Here. So we'll do round, right?
It looks like you can use with column renamed, and you can use underbar 1.
Can you?
It's like it.
Sweet. Okay. Maybe youth can figure it out.
Sure.
Okay, ladies and gentlemen. So this is what we want to do. We want to do round. Oh, sorry. I wasn't careful enough. Hello. Okay, this is not what we want. What's wrong? What's the bug there?
To round
Divided by
10.
10 points.
Yeah, you want to do round of this times 10, right? And I don't even. Sorry, I don't think I need these. Yeah, this is just the close paren, right? There we go. Okay, this is what we want. So here we go. You can see this is a little bit tedious just getting this right with the renames. This is something I don't particularly like. You'll also see it's a little bit confusing because sometimes here you can refer to the typed value if you're dealing with a data set. Sometimes you have to refer to the column, and sometimes you have to refer to the name of the column. It's a little bit, I'm not fond of it. Let's just put it that way. I'm not fond of all this cacophony of different references. Okay, so I need to be careful here. No, that isn't what I wanted to do. Okay, I need to go up here and do round of, no, I could just do it. Yes, okay, I could simplify it this way. Boom. And
One more.
and okay, round. Sorry. So
There's 2 beside round. You probably want to get rid of.
you want to get rid of 1, exactly. Yeah, like that.
They're just copying the one above.
Okay, and And then what I want to do is I want to replace here this guy here, right? This guy. Boom. I want to replace it here by H category. Okay. Unfortunately, it's finicky. I like Kurt's idea of doing that. If you did, so underbar you can do?
In quotations.
Really?
Yeah, according to this guy here, but maybe try to make sure it works.
Okay, this is exhibiting displeasure. Okay, so give me a second. Let me debug what's going on. Probably one of these guys is off. Okay, oh, it couldn't find it. This is what it found instead. Okay, why didn't that match? Oh, that's weird. Oh, okay, it was I see why. It was due to my mistaken parentheses originally. Okay, come on. Okay, come on.
You pasted it twice.
I pasted it twice?
You wanted to copy it, but you pasted it twice.
Is that right? Okay. Okay, thank you. Okay, here we go. There we go. Boom. And here we go. Boom. Okay. Okay. Now sweet. And now what can we do? By the way, you see how I'm debugging this thing. Okay, yeah, now we can do this stat dot crosstab, and we could do age category, and we can do income category, and we can do show. Okay? Or we could reverse them, right? What would happen if we reverse them? Yeah, column and it's transposed. True or not? Indeed. Yea, verily. Yeah. Okay.
What is the advantage of doing all this in Scala? Because we can do this in SQL and can connect to the, like we can create a stored procedure there to get all the data and can just call the stored procedure in here, right?
Yes, but a stored procedure for hundreds of millions of lines of data is going to be extraordinarily slow. And it will likely, in many cases, it will compute things in a way that will be quite burdensome to with the stored procedure to the database server. Whereas if you could do it in Scala across multiple machines, distribute the workload. You can also do it with much more conscious conservation of memory, and generally in a more performant way. And this becomes a big, big issue. I mean, Gin, Narges, Winchell, maybe others here as well. Iden probably have probably all struggled with long-running queries. And by loading this onto a way it can be easily farmed out to different machines, and that you could perform your computations incrementally, you're going to be able to perform the full pipeline for each data item before getting the next one in some cases, which means that you don't have to do a stored procedure, compute an entire data set from that, and then do another thing, compute an entire data set, which is very memory costly. So it's not a trivial thing where the boundary line lies, but we are certainly up against the barrier. I mean, I'm seeing it in my own work where the queries just take a very long time, and where we've tried to use indexing, and we've tried to use stored procedures, and we've tried to use materialized views, etc. And we're just bumping up against the computational limits. And the data sets are only going to get much larger. Particularly with, imagine if this is happening with respect to a couple dozen people follow for 3 months. And now imagine that our partners at a nearby province would like to work with 100,000 people followed for 10 years. It's stored procedure is going to be a totally losing proposition. So this is one of the reasons we want to have access to these tools. Now, for a given computation, a given job, you're going to want to try to figure out, does it make sense to do it in Spark? Does it make sense to do it elsewhere? Another reason of doing this in Spark is, of course, we could add things on here with several different layers of processing. And again, those can occur where possible in an incremental way, which will save memory and be done out on that computation, on that farm of machines out there, instead of just on one database server. Is that helpful? Yeah. Okay, so ladies and gentlemen, we started with a population, simple population here in Scala. We turned it into an RDD. We saw some computations on RDDs. We turned it to a data frame, experimented some with data sets. We saw that the reality of it is right now working in Spark with data, you mix these different things. Sometimes we use kind of a Spark data frame API, sometimes a data set API, type save from data sets, not type save from data frame. Next time, we're going to be loading data in from a CSV file and manipulating it with data sets and data frames. Once again, we'll use case classes. We'll use them to characterize the structure of that data file. And then we're further going to see how you can load in a JSON file. And with JSON, it actually knows, it can actually figure out a lot of the type information directly.
Given
The schema of the JSON file encoded. Now, one of the reasons this is so relevant is, for us as a group, is that Ethica stores survey responses as JSON.
kind of.
Sorry?
Yeah.
Yeah, I mean, there's some metadata about the survey response that's not in JSON, but the actual, I think, encoding of the answer to the questions, the question and the answer, that's in JSON.
Yeah.
And so, when we think about projects that involve taking sensor data in the millions and combining it with survey responses stored in JSON, this ability to kind of read in JSON objects as typed objects, as objects with clear types, extract information from them, and link it with data is really important. And as we'll see, whether it's at an RDD level or at the level of data sets, one of the key things that we're going to want to do is we're going to want to do joins. Okay, we're going to want to join one type of data with another. So if we look at DF population here, you'll notice there's a join here, and just as so much of data frame manipulation is inspired by SQL, but a scalable version of SQL, a version that can run in much more efficient ways than doing it all in a database server. Join, you're not going to do, and this is critical for the excellent question asked by Tina. Really excellent question. Why not do this on a database server? Because, ladies and gentlemen, what happens when you do a join on a database server? It can be extremely, extremely slow to actually perform that. And it can become a bottleneck for other queries that other people have to submit. So we can move the joins off the database server, and we can put them instead onto a farm of machines or onto our computations here, and we can join things which aren't in the SQL database, like JSON files, and join them to things which are in the database, like sensor data, in a scalable fashion. Okay, so we're going to be able to do these joins, and the joins will be done here, and they can be more intelligent in terms of being done on different partitions than we can if we put them out there on a database server, where that's the big bottleneck. And for a lot of the work that we're anticipating, the work of Narjas, the work of Refat, Scott's interests, with databases, large databases, traditional SQL databases, but with very large quantities of data, we're talking about many tables. Narjas may remember, perhaps Refat as well. When we visited Ministry of Social Services, we were talking about they had something like 800, 900 tables in their database. Doing a database join with 3 tables, if you're not really careful, it can bring a database server to its knees. It can be working for 10 minutes, 15 minutes, or longer, depending on the amount of data. If you're talking millions and millions of records and trying to line these ones up with those things, it could be really prohibitive. And that's time that we can't afford to have if many people are accessing it. So we're going to have a way within Spark of doing these sort of operations in a distributed, more memory conserving, which is going to make a big difference, in more savvy way here and with a broader set of data types than we'd be able to with traditional SQL. And we're going to be doing it with a NoSQL database, Cassandra, which is where most of the Ethica data is stored. And we're going to have to do, and we'll be able to do that. Rifat will be happy to hear, using what we've been doing today rather than CQL. Good or not? Okay, so with that, we will close this session, and I'll look forward to working with you on the